Alright, so I have a probability question that says a box contains two white and three blue identical marbles. Alright, if two marbles are picked at random, one after the other, without replacement, right? So they are picked without replacement. One ball is picked and set aside, it's not put back into the box to speak from. They ask, what is the probability of picking two marbles of A says two marbles of the same color, B says probability of picking marbles of different colors. Now let's solve option A first. The same colors. If you look at the question, we have two colors, white and blue. So the probability of picking the same color becomes probability of picking white. Let's represent that as WW plus the probability of picking blue. So that gives us probability of picking the same color. Alright. So this is probability of picking the same color. To find the probability of picking white, since we have two marbles are being picked at random, there is no it's a random selection, there's no order. So we're gonna have for the first pick, we're gonna have 2 all over 5. That's 2 white balls, and we have a total of 5 balls in the box. So 2 white balls multiplied by the second pick becomes 1 divided by 4 because there was no replacement, and as a result, since the first ball was set aside, we're going to have 4 total balls, and that ball, we're assuming that it was white, so we now have only one white to pick from. So that's 2 over 5 multiplied by 1 over 4. So that's going to give us 2 divided by 20, which we will break down, is going to give us 1 over 10. So this is equal to the probability of picking white 2 times, at both balls being white. For both balls being blue, we're going to have the first case, which is when you have 3 blue balls out of 5. And when you pick another one, which we're assuming is blue, is going to have 2 blue balls divided by, you have already picked 1 out of blue, so the total balls now become 4. So this at first is going to give us 6 over 20, which when we break down, we're going to have 3 over 10. So for probability of becoming same color, we're going to have 1 over 10 plus 3 all over 10, which is going to give us, we'll pick the LCM, which is 10, 4 over 10. And if we break that down, that's 2 over 5 as the probability of picking the same color. Now, B says now, find the probability of picking different color. Probability of picking different color. If we have probability of picking same color as 2 over 5, we can use a simple trick. Instead of calculating for different color entirely from scratch, we can use this trick by removing this value from 1. We're going to get a probability of obtaining different color. So we have 1 minus probability of same color. And probability of same color, what we obtained was 2 over 5. So we have 1 minus 2 over 5. If you evaluate that, you're going to have 3 over 5 as our answer for B. So 2 over 5 and 3 over 5 become the probability of picking 2 marbles of the same color and different colors from a box containing 2 white and 3 blue identical marbles. Question 2. We have, what is the probability of getting an even number from 1 to 6. Now, first of all, we must identify what are even numbers. Even numbers can be identified. Okay, let's write that down. Even numbers are numbers divisible by 2. Now, they said probability of getting an even number from this range of number. The range is 1 to 6. So let's list out the range of numbers between 1 to 6. So we're going to have 1, 2, 3, 4, 5, 6. If we identify the even numbers from 1 to 6, we'll pick out 2, we'll pick out 4, and we'll pick out 6 as well. So from this range of numbers, we have 3 even numbers. So we have even numbers are equal to 3, and total numbers are equal to 6. So total numbers equal to 6. Now, the probability of finding an even number is given as the number of even numbers which we have as 3 divided by total numbers, which is 6. 3 divided by 6, if you reduce that to a simpler term, we're going to have 1 over 2, which is half. So that's the probability of getting an even number between the range 1 to 6. Alright, so question 3 says Mary and John have pass probabilities 3 over 4 and 3 over 5 respectively. What's the probability that both boys fail the examination? The probability that both boys fail the examination. When we are dealing with both, we multiply the value of both probabilities, that's for Mary and John. Now, if the past probabilities, let me write that, probability of a certain person passing is X, then the probability of that same person fail will give us 1 minus X, because probability values range from 0 to 1. So for the specific case of Mary, it said they have a pass probability of 3 over 4. So if Mary's pass probability is equals to pass for Mary was given as 3 over 4, so meaning that the fail probability will now be equals to the fail probability still remaining for Mary. The fail probability will give us 1 minus 3 over 4. If you remove 3 over 4 from 1, you're going to have 1 over 4. Then that's for Mary. Then in the case of John, we have that the pass probability for John, according to the question for John, that was given as 3 over 5. So that was given as 3 over 5. Now, to obtain the fail probability, we're going to have 1 removed from 3 over 5. So that's 1 minus 3 all over 5. 1 minus 3 over 5, that gives us 2 over 5 as the fail probability for John. But the set probability of both balls for the examination. Since the probability of both balls, we're going to multiply probability of both Mary and both John. But if we had probability of one of either Mary or John fail the examination, we're going to add. So in this case, probability of both is going to give us 1 over 4 multiplied by 2 over 5, which is equivalent to 2 over 20. So if we break that down, we're going to have 1 over 10 as probability of both balls failing the examination.